Assalamualaikum warahmatullahi wabarakatuh and greetings everyone. My name is Muhammad Izzat bin Zulkifli. I'm from Group ARINC. Today, I will present our group project which is GPS based destination estimator under different environmental conditions. First of all, I will introduce our team member roles. We have a hardware encoding team. Hardware encoding team deals with installation of hardware, software and coding give information to the proposal team. The team consists of me, Muhammad Izzat bin Zulkifli, as lead specialist. Second, Azianti Hanem as specialist 1. And third, Engku Afif as specialist 2. Next is proposal team. Proposal team works together to prepare a proposal with detailed and deep knowledge to the project. Proposal team consists of Christina as lead analyst, Izzat Hafizi as analyst 1, and Crystal Lee Meripa as Crystal Analyst 2. This is overview for our project. Our GPS estimator was tested under 3 conditions. First, closed space and clear sky. Second, open space and clear sky. Third, open space and rainfall. Closed space and clear sky gives the longest time taken to link and receive data from the satellite. Open space and clear sky give off the shortest time taken for satellite to link and give data to GPS. Open space and rainfall in the intermediate time taken for both time to link and receive data from the satellite.
Assalamualaikum and hi doctor. Before I go any further, let me introduce myself first. I'm Izzat Hafizi from ARINC Group. Today, I'm going to present about overview and flowchart related with my group project. Basically, for overview of this project divided into 4 parts, which is destination input, Arduino Uno actuator, testing under influences, and methodology. In this project, Arduino Uno and GPS module will be used to notify the user of the distance to the destination. The latitude and the longitude of the destination first must be defined by the user and data. And data will be input into the Arduino Uno with tiny GPS++ library. Then, Arduino actuator. Once the distance to the destination has been found, user must then insert the range from the destination where the LED light must be turned on as a signal to disclose the user that they are now near to the destination prompt. This project is tested under influences like open space, closed space, and the project is repeated by testing under a clear sky and under the influences of downpour. Then, the result will be used to study the communication between the GPS with the satellite, as there will be variable in the result. For the methodology, there are 2 main parts, which is hardware component and the software implementation part. Then we move to the next slide. Next slide is about flowchart. Basically, we need to select or choose suitable title related to our course. Then we need to submit to our lecturer whether they approve or not about our title. If they are not approve our proposal title, we need to rewrite our proposal, and if they approve, we can proceed with planning process, and once project is done, we need to submit the report and the video presentation. That's all from me. Thank you.
To proceed with this project, it is important to have knowledge regarding Arduino and GPS. What is Arduino? In this project, Arduino Uno is chosen. Arduino Uno is a hardware that is programmed using the Arduino software IDE, which stands for Integrated Development Environment. It is an open source electronic platform based on easy-to-use hardware and software. Arduino can be standalone or connected to a computer via a USB. Arduino boards are able to read input sensors such as light on a sensor, finger on a button, and turn it into output. Output can be actuated, such as activating a motor, turning on LED light, and even publishing something online. The data rate can be viewed in serial monitor in the Arduino IDE. Next, what is GPS? GPS stands for Global Positioning System. It is basically made up of three components: the spatial, the control, and the user. The spatial component consists of constellations of satellites in the Earth orbit. It is conceived so that there are at least 4 visible satellites above the horizon at any point on the Earth's surface and at any height. At a time, GPS receiver receives signals from 4 or more satellites. Next component is the control. Here we have monitor station which track GPS satellite as they pass overhead, collect navigation signal to feed the observation to the master control station. The master control stations provide command and control of the GPS constellations and uses the data to compute precise locations of the satellites. Then it generates navigation messages to upload to the satellite. With the ground antennas, these navigation messages are alerts to the satellite. It communicates via S-band and performs S-band ranging. The last component is the user. It includes all the GPS receiver to receive and convert the GPS signal to position, speed, and time as required. Example of receivers used in this project is GPS module.
Hey, Kristen Lee here. Now, the objective of this team project are to disclose the users when the destination is near through the motor vibration and the light up of the LED light, and to study the communication of GPS and satellites under different users' surrounding conditions, such as open space, closed space, cloudless sky, and downpour. There are several outcomes expected from this team project. Firstly, we should be able to apply and demonstrate the knowledge on the fundamental concept relating to avionic systems such as radio communication and navigation system in daily application. Secondly, we should be able to identify the role and operation of electronic system of radio communication and navigation system. Thirdly, we should be able to deliver the result and findings of this team project effectively through report and presentation. Finally, we should be able to work as a team to solve engineering problems.
Hello, my name is Christina Puchang and I will explain about the equipment and also the software that we use to conduct the experiment. So first, as shown in this slide is the main hardware component that we use to conduct the experiment, which is the Arduino, GPS module, and also the motor driver. So for the Arduino, types that we use is the Arduino Uno, and as we know, these types of microcontroller is used to perform a task given by giving the instruction into the board. While for the GPS module type is the Neo-6M. So this GPS module is used to communicate with the Arduino via set of communication by using the TX and RX pin, while for the dual bridge hedge motor driver that we use is L293D. So the function is to convert the low current signal to the high current signal. Next is the list of the component required and also the quantity that we use to conduct the experiment. So the equipment is including LED light, vibrating motor disc, protopod, battery, and also the jumper wire. So next is the software that we use to conduct the experiment is the Arduino software IDE 1.8.15 version. We use this software because it is the open source and easy to use software, while the library that we use for this software is the Tiny GPS++ library. So this Tiny GPS++ library function is to extract the GPS data from GPS receiver, such as the position, date, time, longitude, and latitude. While this library also can provide a simple method for extracting the data. That's why we use this software for this experiment. So that's it for this part. Thank you.
Throughout this project, we have discovered a weakness in our device, and here we are going to suggest a solution to make the device better. After conducting multiple tests with our device, we found out that the GPS signal from the satellite is too weak. After the signal travels a very long distance, it is barely enough for the GPS receiver to detect it and use it to calculate locations. Any obstruction between the antenna and the sky will further disrupt the signal. A wall will cause the signal to be blocked or deflected, and making it impossible to calculate locations indoors because of insufficient signal strength. Therefore, to counter this problem, we looked at options besides GPS, such as Wi-Fi based positioning system, or also known as WPS. WPS can be used to improve indoor tracking by using Google's database of access points to calculate the location. By doing this, we can improve the overall performance of our device.
For future analysts, using other types of GPS device could display a different result from this project. Our project can be concluded as a success. Our objective were achieved. Okay, that's all from our team. Thank you.